Hi, thank you for the introduction. My name is Aftandilian. I'm a researcher in GitHub Next, where we build new tools to make developers happier and more productive. We created GitHub Copilot, and we're now looking at the next generation of these tools. Over the past few years, there's been an explosion in AI-powered developer tools. These tools are accelerating software development, and the trend will only continue. In this talk, I will discuss what these tools are good at and what they're not, what they mean for engineering teams, and where they might be going in the next few years. So first, let's talk a little bit about what the current tools are good at. So the first and most obvious thing is completing code. So this is the Copilot style of complete the line that I'm about to type or complete the function that I'm about to type. And it makes sense that LLMs would be good at this because this is precisely what they're trained to do. They're trained to predict the next token. You can just string a bunch of next tokens together, and you get a completion. Yeah, it makes sense that LLMs would be good at code completion. But they're good at certain aspects of code completion. So they're very good at using libraries. So LLMs have been trained on effectively all of the open source code in the world. They've seen every use of any open source library that you can imagine. They've seen effectively all uses of them. And so they know how to use these libraries, and they know how to string these library calls together to accomplish a task for the programmer. They're very good at this. Another thing that they're very good at is using idioms, right? So for any given programming language, there's like a certain idiomatic way to write a snippet of code, right? So if I'm writing Python and I want to loop over a collection, maybe I want to use a list comprehension because that's the Pythonic way to do it. But in Java, I would write a for loop or something like this. What are idioms? Idioms are just the most common way to do something in a given programming language. And again, that's exactly what these models do. Given some context, they predict the most likely next completion or the most common completion that they saw in their training set. So LLMs are very good at using idioms to write code in a very sort of natural style. Finally, LLMs are very good at adapting to local context. So this is things like using the correct code style for the file that they're in, or using variable names that are described the same way that the other variable names are in this file. There's a common misconception that these LLMs are effectively just large lookup tables. It's like kind of doing a search over the internet or Stack Overflow and then copying and pasting. But that's an oversimplification. They're actually very good at adapting the code that they want to write to the current context. So if you're in a file and you're using tabs as your indent mechanism, they'll use tabs. If your variable names are in camel case, they'll do camel case. If they're all one letter, they'll do one letter. They're very good at these kinds of things. And all of these characteristics of LLMs help keep the developer in flow. And flow is very important, not only for productivity, but also happiness. So what are they not good at? And note the yet here. People are working on all these things, and the answer will likely be different a month from now or maybe tomorrow. We'll see what comes out on Twitter today. So the first thing they're not good at yet is understanding large systems. These models have a limited context window. You can think of this as like the short-term memory of the model. And with sort of the previous generation of models, this was maybe a few hundred lines of input that they could process. And so they're generally trained only on single files, and often not even the whole file, because the whole file can't fit in this context window. And therefore, they don't really understand how a project with many files fits together. Another thing they're not good at yet is actually doing things, right? So currently, we communicate with these models through text, either in Copilot by the model suggesting the next line of code, or in ChatGPT by just chatting with the model and reading its output. But they can't actually accomplish things for me. You can't ask them to debug this issue or rewrite the code in this file from JavaScript to Python. They have no agency. You can do some of this by hand with Copilot or ChatGPT and prompt engineering, but you end up in this sort of frustrating cut and paste cycle. And finally, the last thing that the current tools are not good at is explaining themselves, like understanding why did the model give me this suggestion? So fundamentally, we really don't understand yet how LLMs work and why they produce the outputs they do. And this is why it's so important for humans to be in the loop with these models. But when the developer reviews the model work, it's important for them to understand why the model produced that output, and if it's not right, how to nudge the model to produce the right one. And we're not there yet on explainability. So given this current state of the world, what does this mean for engineering teams? So first, it's becoming clear that developers are much more productive when using these tools. So this figure is from a study that we did at GitHub with some Microsoft colleagues, where we gave a set of about 100 professional developers a standard coding task. In this case, it was implement a web server in JavaScript. And we gave about half of those developers Copilot, and half were not allowed to use Copilot. And the ones who used Copilot completed the task 55% faster than those without. In addition, the telemetry we collect from Copilot shows that about 35% of code written by Copilot users is actually written by Copilot, as compared to the user actually typing the characters. And it's important to note that we're just at the beginning of this. This is just the first generation of these tools. And so productivity is only going to increase as these tools improve and as new tools hit the market. All right. So another thing that engineering teams need to know about these tools is that developers still need to design and they need to steer the models, right? So these tools accelerate developers, but they don't replace them. The developer still needs to design the high-level architecture of the system, and often even within a particular file, still needs to provide the skeleton of what they're trying to accomplish, and then the model can fill in the details. The developer has to review and edit the AI's suggestions. The models, don't. I think we've all seen this. The models will make stuff up. They often are not correct in what they're suggesting. And so a large part of the developer's role here becomes reviewing the suggestions made by the AI and either rejecting them or fixing them up so they actually do what the developer wanted. And finally, good engineering practices are still good engineering practices. So these models, they're trained on open source code. They'll make the same mistakes that they saw in the training set, and these are the same mistakes that humans make. And so the same engineering practices you need for humans, you need for AI-assisted humans. So you still need things like automated testing, linters, static analyzers, code reviews, all these good practices. You can't stop doing them. You still need them in this new AI world. So another thing that I think is going to happen is that junior engineers are going to start designing larger systems, right? And the reasoning for this is that AI is pretty good at accomplishing sort of smallish tasks for developers. And so this means the developer's time is going to shift. They're going to shift their focus from the sort of low-level tasks to a higher level of abstraction. A developer is going to need to identify the tasks to compose, to complete a project, but they're not actually going to implement those things themselves anymore. And so I think that as time goes on, we're going to be asking junior engineers to do bigger things like designing systems and let AI handle the details. And so when you're hiring, you might want to consider asking system design questions, even in your junior engineer interviews. And maybe you also want to provide them training for system design and coaching specifically for this. So another thing that we're seeing with Copilot is that a larger fraction, or a completely new but large fraction of the developer's time is spent reviewing AI suggestions. So this figure is from a paper by Microsoft researchers, where they observed Copilot, users using Copilot. And they sort of binned the user's time into different activities. So they came up with a rubric of like, here are all the activities that developers do when they write code, and then they watched the developers and for every minute recorded, in which activity were they. And they found that the most common activity that these users spent time in was this thinking, verifying, suggestion state, which is just reviewing Copilot's output. They found that 22% of developer time was spent in this sort of reviewing the AI-generated code. And it's important to note that this category doesn't exist without an AI code generator. This is an entirely new activity that developers are taking part in. And so you should consider, again, revising your hiring process to test for this. Less giving sort of coding from scratch interview questions, and more give the candidates some code and ask them to explain it, modify it, debug it, and so on. And then finally, AI-assisted developers, I think, are better generalists. So consider programming language specialization, right? So currently, you need someone who's really fluent in a programming language to be productive. But with AI assistance, a developer can very quickly become productive in a foreign language. And the reason for this is that really the language syntax is not the hard part when you're writing in a foreign language. It's the libraries and APIs. And I already discussed that this is one thing that these models are especially good at, right? So, when I came from Google, I was a Java programmer, and at GitHub, I've mostly been writing TypeScript and Python. And I found it super easy to ramp up, because most of the time I can write a comment that's just, do this in, TypeScript. And I get something plausible out of Copilot. It may not be exactly right, but it's much quicker than me, searching Stack Overflow, figuring out what's, out of the 10 ways to do this, which one do I want, and then, writing that down and figuring out whether it works or not. So I think AI-assisted developers are already better generalists, and they're going to become even better generalists and more flexible with newer tools. All right, so I wanted to talk a little bit about what's next, look into my crystal ball. As other people have said up here, this field moves super quickly, and what I say right now might be dated, from the time I wrote this to now. But here are the things that are kind of top of mind for us in GitHub Next. So I mentioned earlier that the current generation of models have limited context windows, which again you can think of like short-term memory. And this effectively limits them to work on a single file at a time. You can play tricks to get around this, like retrieval augmented generation, but it's never going to be as good as if the model could natively process a large amount of data in a single prompt. But we're beginning to see models that have much longer context windows. For background, when we launched Copilot, the state of the art were Codex and GPT-3, and those had 2048 token context windows. But GPT-4 has a 32K token context window. Anthropic's Claude has a 100K context window. And just recently, Magic announced a model called LTM1 that has a 5 million token context window. With these very long context windows, you could show an entire repo to the model, and it could summarize it for you, tell you where to make a change, maybe create architecture diagrams for you directly from the source code, these kinds of things. This is going to be a big change and is going to enable new types of AI developer tools, things that were completely infeasible before. Second, as I mentioned earlier, the current generation of AI dev tools lacks the ability to perform actions on the user's behalf. Right now, you're limited to this text-based input and output. But we're beginning to see models trained to use tools and to take actions, such as Adept's Act 1 and the ChatGPT plugins that I'm sure many of us have played with. A tool in this context you can think of as anything a human might use to solve a problem. For example, a calculator or a code interpreter, a search engine, these kinds of things. And an action you can think of as something like editing a file, clicking a button in a UI, et cetera. I think there's huge potential here. Imagine a developer offloading small tasks like write a CI script to build and test my project and make sure it works onto an autonomous agent so that they can focus on the bigger picture. All right, so we talked about explainability a bit, but these first-gen AI dev tools, they produce some output, but they don't explain why they gave that output. Newer prompting techniques like chain of thought and action plan generation, they encourage the model to break down its thinking into steps. And the first order reason for doing this is that it improves the quality of the final answer, but it also lets the user review the model's thinking and understand why it answered a certain way, maybe review the chain of thought and point out flaws in the thinking and allow the model to correct it. And this is going to be very important as these tools start taking on more and more complicated tasks so that we humans can review their work. So in summary, AI developer tools are transforming software development. They're making developers happier and more productive. They're shifting developers' work from writing to reviewing code. And there are a number of exciting developments on the horizon, such as agents that can accomplish tasks on the developer's behalf. Thank you for your attention.